that's really long. So what people call this is a telescopic op-amp. And the reason is that it's so long. It's spread out top. It's just the longest it could possibly be. So it's called a telescopic op-amp. Gain boosting is the most complicated, and let's see, I'm going to give it a go, but it's much better to do in person to try to explain this. Okay, so gain boosting is something that, if you remember, if you have two transistors cascoded, and up here there's two more PMOS cascoded in this case, since these are MOSFETs. So there'd be two PMOS cascoded up here. Okay, if you remember, the R looking down here is GM1, so the GM of the second transistor. Okay, and then you have the RO of M0 and RO of M1. So this is the R looking down into that transistor M1. Okay, again, the input goes into the bottom transistor. Okay, now let's see what cascoding does, what gain boosting does. So gain boosting, it doesn't change RO or RO1. Doesn't change either of these resistances. What it does is it increases GM1. Okay, so let's think about what GM means. GM means is when you change the voltage in, the current out changes. It's the ratio of how much the current out of your amplifier changes over the change in the voltage into your amplifier. So I out over V in. Okay, so if you thinking, oh, wrong color. Pointer options, pin. How about, no, it's not going to let me pick a color. All right, so I'm going to draw a box around this. Okay, and there's some current going in. Here's some voltage going in. So this is your I. In general, you define this I out. Sorry about the mouse. It's not working very well. This is negative I out. Generally, I out is defined as positive out of the circuit. Okay, so let's see. So the GM of a single transistor, let's say you had a BJT. You have V in, say this is grounded, and then you have this IC. Okay, the GM is, if I change V in a little bit, how much does IC change? So what you get is, geez, sorry, over change in V in. So that's the change in IC over the change in V in. That's your transconductance. Okay, let's go over here for a second. Here's your V in, and here's your, let's change this to IC. We'll just change this to IC. IC. Okay. No, what the transconductance of this thing inside this red square, it doesn't have to be, you don't have to know what's inside of this red square. You can still figure out GM. If you change the voltage in and see how much the current changes, that's your GM. Don't need to know whatever's going on in here. Okay. For the VN, we have that equation for IC. IC equals IS. I can't draw it. IC equals IS e to the VBE over VT, where VBE is VN. That's how you find your transconductance for a single transistor. Let's see what Pointer options, ink color. What's a good color to change this to now? Can you see blue? Okay, so let's look at what happens here. You know, for this example up here, you just move VN up and IC goes up. Okay, let's do the same thing here. Let's move VN up just a little bit. Okay, and let's say this node, just for a moment, this node right here doesn't change. So if I change VN, however much I change it here, that's the change in V, the input to this amplifier right here. Okay, if I change this delta V, I claim that this node right here goes up by AV delta V. Okay, so I change V in by delta V. If we assume this node isn't moving right here, then now you've got delta V change between the plus and minus terminal of your amplifier. Okay, and whatever the difference between these two terminals times the gain of that amplifier, that's how much this node right here is going to move. Pointer options, ink color, should we go back to bright green? Okay, so that's how much this node right here is going to move. AV times delta V. Okay, you only changed V in by delta V. Okay, well let's do that over here then too. Golly, this mouse is nasty. Okay, let's say I changed V in by delta V. VBE has only changed by VBE, by delta V, sorry. So if I move V in by delta V, that means the VBE of this transistor has only changed by VBE. Over here, if I move the input by delta V, I'm actually moving the base voltage, in this case the gate voltage, by AV delta V. I'm multiplying whatever change in Vn I have by AV, and that's what's actually getting to this transistor. So if I move the gate voltage that much more, that means I'm going to get that much bigger change in current. And remember, it's the change in current over the voltage in that gives you transconductance. So over here you multiplied it by, you changed Vn by delta V and you got some change in IC. Okay. Then over here with this amplifier in there, you change this by the same delta V, but you got a much bigger change in current because the base voltage is actually moving way more than delta V. Okay, so if you just had this black box right here, and you change it by delta V, you'd see a much bigger GM than you would with a single transistor. And if you're in a linear region, you actually get AV. If you're in a linear region, you actually get AV times your GM1. That's your new GM for this item in the box here. Okay, I really hate to do this on video, so we will talk about this again, but it's really hard to tell, because this is one of the most difficult kind of concepts to grab when you're talking about increasing gain. It's this gain boosting. The whole idea is to draw a black box around something, change its V in, and see how much the current changes. If the current changes a lot, then whatever's in that black box has a high GM. If whatever's in that black box doesn't, the current doesn't change much for a delta Vn, then it has a low GM. And by adding this amplifier right here, you can get a big change in the current for a small change in your input. And that makes the GM of this black box big. And this thing in this black box here, that black box is when you cascode transistors like this, the R out has a terminate that is the GM of the not the input transistor.